So as Sergey said, we're going to talk about the module we developed called Modeling the Dynamics of Cultural Diversification. And before we start, I just want to quickly recognize the contributions of some of the other colleagues to this. Bernie and I were the lead designers on this project, but our research generally has been helped out by a number of other colleagues in evolutionary biology, specifically Jonathan Chang and Mike Alfaro, Daniele Silvestro, who is a paleontologist, and Jacob Foster, who is a sociologist. So we've had a nice interdisciplinary team that has helped work on a lot of the research that we'll talk about here today. So I want to start out then by just talking about the justification or why we started to develop this particular module. And so when we originally applied to develop a module for these Cultural Evolution Society modules that were funded by the John Templeton Foundation, we wanted to sort of hit on some of the key goals of these particular modules. One of those was to introduce sort of dynamic modeling frameworks. As we've discussed in earlier webinars, modeling has been an important part of cultural evolutionary research. And we hope that our module can at least help in sort of having people gain familiarity with certain modules and modeling approaches. So in addition to this, the goals of the CES modules also included sort of investigating common problems in cultural evolution, encouraging the application of computational frameworks, which of course also often coincides with modeling frameworks, and really to also provide a range of educational modules from both introductory levels to also more advanced practitioners. And in that sense, our module that we present today is probably more towards the latter half of these, in the fact that it's perhaps a bit more math oriented and a bit more focused on the methodological decisions that we use surrounding our modeling framework. And we hope that that can be of some use to people interested in applying various cultural evolutionary methods. So really based on these broader cultural evolutionary society goals, our module specifically has a number of goals that we developed. And one of the most broad is to encourage a macroevolutionary approach to the study of cultural change. We'll sort of talk about what we mean by a macroevolutionary approach and what we see as sort of the key themes are in a macroevolutionary analysis. And the second then is also to help sort of expand the toolbox in cultural macroevolution. In general, there's been an extensive application of a few key methods, such as phylogenetics, which I'll talk a little bit about in a few minutes. But we do feel that those are a number of other approaches that are available that can be useful to answering questions about cultural macroevolution. And we hope to introduce those here today and also through our module. Sort of our third goal extends more directly from some of these broader goals. And that is really to highlight a quantitative and probabilistic approach to modeling cultural diversification. I think it was in the first webinar that Paul Smaldino really was talking a lot about models and how we use models and the range of quantitative training that has been available in the social sciences and how variable that can be. So we're hoping to at least provide an introduction and get people familiar with some of the modeling frameworks that we use, specifically the sort of probabilistic and Bayesian one we talk about in the module. Overall, our module is divided up into 5 different tutorials. The first really looks at the conceptual foundation of cultural diversity and how we think about patterns of cultural diversification. This is the section I'll talk about more specifically today, as I think it probably has the broadest appeal. The remaining tutorials then look more specifically at implementing the approach from a methodological perspective. Specifically a program known as LightRate, which is a program we developed to implement a birth-death model and estimate rates of diversification. This particular program runs in Python, and so we also try to build in sort of experience in coding in Python and seeing how the code we develop looks like in Python so that users can look at it and really interact with it. There's a supplemental module that examines the application of phylogenetic inference to cultural data and sort of various decisions that go into the construction of cultural phylogenies. I'll talk a little bit about the phylogenetic approach here, but that's really a sort of a supplemental piece of our modules. there's a lot of great tutorials already available for applying the phylogenetic inference in cultural evolution. And so we didn't feel like we needed to redo those here, but simply sort of point to those in the supplemental tutorial. Just a quick note on the modules themselves. When you look at them on the Cultural Evolution Society website, on the Dysoc website, ours are a little different in that they are presented in Colab, Google Colab. So if you're not familiar with Google Colab, it's meant to sort of combine both text and images, but also be able to write and execute Python scripts and even some R scripts that we have in there as well. And so we're really hoping that by doing it in Colab, we could provide a bit more interactivity between the module and the user. You could see the code chunks we have, you could run the code chunks we write, you can write your own and try to write them. And so I think Bernie will try to demonstrate that a little later, what that exactly looks like. For those of you familiar with IPython or Jupyter notebooks, essentially Colab is exactly one of these, except it's based, it's browser based. It does require a Google account to use, and it tends to work best in a Chrome browser, but it can work in others as well. So that's just some general housekeeping about the modules themselves. All right, so let's talk about some of the sort of broader background of our module, which is really trying to tackle this idea of the analysis of cultural diversity and diversification. So inevitably, a talk about cultural diversity starts with the endless discussions and debates around what the definition of culture is. Anthropology and many of the social sciences have gotten by over the years with a wide variety of definitions of culture. Many of you may be familiar with the definition provided here, which comes from Not My Genes Alone, as well as many other publications. And this is really the idea, right, that culture is information, and it's information that's capable of affecting individuals' behaviors. And perhaps more importantly, that it's information that is acquired from other members through social learning or through teaching and imitation and other forms of transmission. That's really one of the core arguments here of this particular definition. We really look to supplement that particular definition by maybe further dividing it into the notion that culture is sort of a population of not only related representations, so sort of mental representations, but also of physical objects that circulate between people. And so it's this sort of pulling it apart into these two other interacting aspects of representations and objects. And really what we want to focus on is that there is a sort of public part of culture. There's a material representation of the beliefs and skills and values and practices that we see. So that may be social media data, that may be art, that may be folktales, as Joe Stubbersfield talked about a few weeks ago, artifacts, song lyrics. There's a number of different types of cultural data that can be used that sort of fall in this domain of sort of material objects or public culture. And it's really this latter set of objects for public culture that we want to focus on and really try to develop methodological approaches to examine this type of data. So what do we mean when we talk about cultural diversity? Well, we're really just talking about the real variety or totality of these things that are circulating within and between individuals, the combination of representations as well as material objects that are there. And inevitably, right, the cultural diversity that we see is a product of the cultural transmission processes that underlie it. And a substantial amount of cultural evolutionary research has gone into looking at both the empirical and experimental evidence for these transmission processes. And we've heard quite a few about those over the last few webinars. And so we won't sort of discuss them in more detail here. I think what we are more interested in is a sort of macro perspective on cultural diversity and really the distribution of cultural forms or traits that can be studied sort of cross-culturally and often at longer timescales. And so in that sense, what we're really trying to get after is a sort of broader scope of the distribution of cultural forms and traits. And this may be what is often considered a macroevolutionary approach. And rather than discuss sort of a very specific definition of what is it or is not a macroevolutionary approach, I think it's easier to highlight some of the key themes that often fall under the umbrella of a macroevolutionary perspective. So that would be things like estimating rates of evolutionary change, perhaps identifying transitions in the historical record of culture, exploring the many other dimensions that may affect cultural change, whether those be historical, demographic, social, environmental factors. Occasionally, if possible, associating different patterns with underlying processes. So looking at a pattern of distribution of cultural traits and identifying whether this is associated perhaps with a process of competition or adaptive radiation, maybe assessing something like the Red Queen hypothesis. And then what I think the last point here is that often what macroevolutionary approach is trying to do is reconstruct evolutionary relationships. Often this is through a phylogeny or phylogenetic approach. And that has been sort of the largest focus, I think, of previous research, and one that I'll sort of talk about a little more. So nearly over 20 years ago now, Boyd and colleagues wrote a paper, Are Cultural Phylogenies Possible? And this really highlighted one of these ideas of, how do we use a phylogenetic approach when dealing with different aspects of culture, and whether or not we need to see or view culture as being transmitted in different sort of forms, whether that be something like cultural cores, which were typically seen as sort of more coherent bundles of shared traditions. These tended to have more stability, maybe more vertically transmitted. And it was really, we were after sort of those aspects because it was thought that these would be able to help reconstruct deeper histories. It would really be able to help reconstruct population histories if we had a reliable set of assumptions that these components of culture were transmitted in these particular way. Whereas with packages, these are tending to be viewed as maybe smaller bundles of traditions, perhaps a bit more variable or permeable, and maybe more influenced by horizontal transmission. And it's not that a phylogenetic approach can't be used in this particular case, but it there is a bit more of a nuance on whether or not the tree we're developing really can reconstruct deep histories when we're dealing with aspects of culture that can be sort of more viewed as cultural packages. Now, this question of are cultural phylogenies possible, if we fast forward to today, I think there's still varying opinions on how applicable the phylogenetic approach is. I think we've seen some really excellent research done with the phylogenetic approach, especially when looking at languages. One of the sort of earlier papers on this by Russell Gray and Quinn Atkinson, reconstructing the language tree for Indo-European languages, was an excellent example of this, and we've seen a number of examples sort of use similar approaches. Where we've seen a lot of the sort of, in my opinion, the best work done has been in the comparative methods approach using phylogenies. So this was sort of originally discussed by Ruth Mace and Mark Pagel, and really applied in a number of different circumstances, using the sort of backbone of the linguistic tree often, and then looking at sort of the correlated evolution of coevolution of different traits, whether that be things like matrilineal descent and the use of cattle, as is in the case of Claire Holden and Ruth Mace, a paper from 2005, I think, or whether that be sort of a more recent example where Joe Watts and others looked at the sort of coevolution of ritual human sacrifice and social stratification. And so that's where we've seen a lot of benefit of the phylogenetic approach in asking some of those questions. Application of the phylogenetic approach outside of language, though, it has been a bit more mixed. Research by Mike O'Brien, Briggs Buchanan, and others have really shown the utility of a cladistic approach, possibly things like reclassifying material culture typologies, such as projectile points. Although in some cases, as in the paper by Temkin and Eldridge, they make a very clear statement that, at least in their view, traditional phylogenetic analyses have rather limited application for unveiling material culture phylogenies. And so, at least in my opinion, there remain some real concerns about constructing phylogenies when we're talking outside of languages or well-known cultural systems, such as folk tales or other systems that we've heard about in some of these webinars. And at least in my opinion, some of these concerns are due to things like an inability to sort of a priori determine which traits are most similar due to descent, and therefore should be the baseline data for a phylogenetic analysis. In linguistic analysis, this is often the use of Swadesh words or words that are assumed to be more stable through time and therefore provide the best evidence for the best data really for tree building. I think in other cases, it can be difficult to assume that some cultural systems have a strong branching pattern, and that we at least need to consider the potential strong influence of horizontal transmission on cultural objects. Two of the other concerns are more methodological in nature, specifically the need for very detailed trait level cultural data, as we saw with Joe Summerfield's talk with folktales. Often they use the ATU index, which classifies folktales and gives information or classifies the characters that are used as well as the themes that are used. And I would argue that there are many aspects of sort of public culture that do not have this level of detailed data. And to get that level of data would be very time consuming and difficult to collect. We also know that phylogenies have challenges in estimating rates of extinction. And this might be quite an important deficiency in that those periods of cultural loss where we're seeing diversity really decrease significantly, maybe some of the points in time that we're most interested in studying. So that's sort of a long-winded way to get at this question that we originally started with when we did this research, or when we started this research project, was can we examine patterns of cultural diversity without using a phylogenetic approach? So to answer this question, we took inspiration really from decades of paleobiological research, which we felt was maybe similar in our attempt to try to draw evolutionary conclusions, but do it from a very sparse and often patchy fossil record. And the argument that we sort of suggest has its origins in much earlier works like G.G. Simpson's Tempo and Mode of Evolution, works by paleobiologists like Michael Raup and J. Jespkowski, Stephen J. Gould, is that when using historical and sparse data, often like fossil data, or in my case, archaeological data, the focus should be more so on reconstructing rates of evolutionary change and really getting a broad picture of the temporal dynamics or the temporal patterns of diversity. And that's not to say that reconstructing phylogenies and really emphasizing historical relatedness is not important, because it is, but rather that the nature of some cultural data lends itself more towards questions about rates of diversification and changes in diversity over time. This conceptual shift, I think, is perhaps best summarized in this book by David Jespkowski called Rereading the Fossil Record, which gives a really wonderful historical account for the rise of quantitative paleontology, and there are the conscious effort by researchers in that discipline to reorientate the discipline to questions, quantitative questions about evolutionary rates and how to deal with them. So one of the most significant differences then in sort of our approach to cultural macro evolution is that we very much focus our unit of analysis on the lineage. And so what do we mean by a material culture lineage? Well, we define lineage as a suite of features that persist in generation after generation of artifacts or objects, really, and display relatively minor changes through time. And so in this sense, we're very much prioritizing the historical continuity of objects. And so, for example, in a recent paper that my colleagues and I did, we looked at pottery styles from the linear bandochramic culture of the Middle Neolithic in Central Europe. This has been a data set that has been used by a number of evolutionary oriented archaeologists. And for each of these, then our lineage was a pottery style. We felt like we had a pretty good sense that we had traits that were sort of fairly coherent for each of these styles. And then using radiocarbonates that had been developed, the radiocarbon database developed over the years, we then tried to put a sort of temporal ranges on these particular pottery styles. And that's what we then had the central unit of analysis, was the combination of both the pottery styles as well as their temporal duration. And so one of the key methodological insights that were made by paleobiologists is that if our focus is going to be really on looking at changing diversity through time, looking at temporal patterns of diversity through time, we actually don't need to reconstruct the tree if we're just sort of looking at sort of changes in the number of lineages. We actually only need to know the duration or the lifespan of the different lineages. So we only need to know the sort of time of first emergence and the last time we see these particular lineages exist. And with that information, we can get roughly the same sort of ending point, which is in something like this, which is a clade diversity diagram, in which we can sort of identify sort of how diversity changes through time. So in that sense, our approach really prioritizes our ability to quantify diversity, as really the inferential power of our analysis is very much dependent upon how confident we are in grouping things. Now, just as a sort of quick clarification, I'm using the sort of term diversity here to describe how we classify these things. And really, diversity can be roughly divided into two main properties, right? Richness, simply the count of how many categories we have or how many lineages we might have. And then evenness, which then highlights sort of distribution of things between these particular categories. Often these properties are measured then by a variety of diversity indices, things like simple counts of lineages, as I had showed in the previous slide, but also things like the Shannon-Weaver index, the Simpson index. There's a whole variety of diversity indices that I'm sure most people are familiar with. Well, these diversity indices have been very useful in a lot of cases, especially when measuring diversity at static or single points in time. They are very static statistics that have limitations when we want to examine more dynamic cultural systems. And some of these limitations are that they're challenging to compare with each other when data is quite variable. We're often maybe comparing temporal periods that have different ranges, 50 years, one might have a 200-year time interval, different sampling sizes, different regions have different sampling intensities. And this can make these different diversity indices challenging to use. It also doesn't necessarily account for the fact that diversity is very much an evolutionary process. The diversity we have today, the cultural diversity we have today, or even the biological diversity we have today is a product of the diversity from previous time periods, from yesterday, from the years before, from really the entire evolutionary history. And so by taking diversity indices at single snapshots, we sort of don't properly account for that sort of trajectory that we see that is so important when talking about diversity. And so this really means that these often have limited insights into rates of evolutionary change. So what are we sort of arguing for? Well, the argument can most simply be put down as sort of what we're trying to do is really transition from quantifying cultural diversity to modeling cultural diversification. That's what we want to try to do. And so how do we actually go about doing this? And this is really what our module tries to do. We look at the sort of type of data that we might need in order to have a more dynamic modeling process, as well as the type of methodological considerations that we need to have, looking at something like instituting a continuous birth-death model or the Bayesian modeling framework that we talk about here. And so this is really what we're going to try to emphasize. I'll talk a little bit about cultural richness data, longitudinal cultural richness data, and what we mean by that. And then Bernie, I think later on, we'll talk more about sort of the modeling framework that we use. So to just give you a real brief example then of our particular approach, I want to highlight some of the work we had previously done that was looking at the diversification of American automobiles. And in this sense, we really were just trying to develop a more proof of method sort of research, and by asking fairly two simple questions. And that was, what are the rates of origination and extinction within American automobiles? And does the diversity of American automobiles change gradually over time, or does it tend to be more rapid or punctuated? And we really didn't know what to expect when we tried to ask these two particular questions. So in order to answer these questions, what type of data do we need? Well, we need sort of what I call here longitudinal richness data, sometimes called time transgressive richness data, sometimes referred to as occurrence data. And really, once again, the focus is on sort of our ability to group things and how well we can group things together, that being our cultural lineage. And then putting sort of time intervals on that cultural lineage. When did that lineage first emerge? and when is the last time we see that lineage exist. And with car models, it's actually quite easy, as we have very good data on this particular timings of production. So you can just see the sort of structure of the data here with three real simple examples of a Corvette, a Mustang, and a Viper, the years in which those car models were first put into production, and then the last year of production, some of them still being produced. And so in that case, the last year of production is 2020. So why do we do cars? Why do we choose cars? I'm not a car guy. You know, I wasn't really sort of interested in doing cars, but you know, you can make a strong argument that automobiles are perhaps the most significant innovation of the 20th century, and it have a massive impact on human mobility, on globalization, and even on climate change. From a methodological perspective, they're quite easy to work with. They're a very diverse system, but we also have nearly complete historical data, especially on the years of production for most car models. And so in this case, a car model is our lineage. That is what we use as our unit of analysis. There's also a fairly well established classification scheme where you have a make, model, and a trim. Make being the manufacturer of the car model name, sort of indicating what that is. Once again, that's our lineage. And then occasionally you'll have something more specific like the trim, which is a specific version of each particular model. And we see we have a wide variation in model lifespans as well, which also made it useful for us to look at from a macroevolutionary perspective. So just to sort of give a brief example here then, this is simply looking at a sort of raw diversity index, in this case, just richness. So counts of car models produced in each year. So this data was taken from eBay, which runs a very large, very complete database of all the car models and when they were produced. As in order to sell a part online, sell a used part for a car, you need to identify what car model it originally belonged to. And so they have a very good database on this, on car models. So we can see here that looking at just richness, we see a general increase in richness through time, really with a very strong increase in richness from just after World War II in the mid-1940s up to the 1980s, which in that case we see a decline in overall richness from the 1980s to the probably about 2015, 2016. If we look at in terms of lifespans, we can also see this pattern where we see car model lifespans between basically 1900 and 1940 being much shorter than car model lifespans really after post-World War II. There's a number of reasons why that happens, but we can clearly see this dynamic, especially in the graph on the right, of very short lifespans early on and much longer lifespans later on. So if we look at sort of this dynamic, we can probably make a number of inferences about what the richness looks like in this particular case and what information it provides to us. But if we split this then down up or sort of drill down into this and really talk about the origination and extinction rates and really dissect diversity into its constituent parts of origination and extinction, we see a much more dynamic process here. We can see, at least in this particular case, we generally do see an overall richness, increase in richness. So we generally see origination rate being higher than extinction rate, meaning that we are increasing in overall richness. But we see a much more dynamic picture for how origination and extinction relate to each other and how they are changing through time. We can see the impact of specific historical periods, a massive decline in both the origination and extinction rate after World War II. We see a very much an increase in the diversity, so a much higher origination rate just after World War II, and really the emergence of car culture in America during the late 1940s and early 1950s. And then we see some other dynamic processes. We see evidence of sort of the oil crisis in the late 1970s, or early 1980s. And we also see the rise then of, towards the end, year 2000 and into the 2010s, this decline in diversity and the loss of car models, where we see the extinction rate higher than the origination rate. And really what I want to sort of highlight here is what a more dynamic picture we get when we disentangle diversity into diversification rates, and we're actually looking at evolutionary rates of change like origination and extinction. I think that's really what we're trying to get at here, is use diversification rates to give ourselves a better understanding of cultural diversification. So with that, I will sort of then hand off to my colleague Bernie, who will talk much more about sort of this process of diversification rate analysis, how we actually go about developing these measures, and give another example of diversification rate analysis of black metal music. So I will stop sharing my screen, and hopefully Bernie then will start sharing his.
Howdy, can people hear me and see me? Yeah, great. Let's see. So yeah, so I'm going to talk a little bit about kind of the methods here in a little bit more detail, and show you how these methods can be used to identify historical events or the action of evolutionary mechanisms in real data. And so I'm going to use an extended example, which is the one that we use in the tutorials, which is kind of a macroevolutionary history of metal music from 1968 to 2000. Cool. So just to recap, I think it's easier for me to think about the methods, recap what Erik said about the theory and about how I think about the theory. I'm a sociologist, so I don't really know how different or similar this is to how anthropologists think about it, but I'm happy to talk about it more at the end. And yeah, so, you know, culture exists. Culture is both personal and public, right? It exists both in people's brains in terms of beliefs, skills, values, practices, mental representations. And it also exists in the products of social action. So these are things like institutions or material objects, which we focus on here, public representations, relational structures. And yeah, and so the transmission and variation of culture comes from learning from and reproduction of objects. So we learn and reproduce objects, which changes our own kind of personal cultural representations or ideas, and we reproduce those for others. And you guys all know about, I mean, this is a cultural evolution thing. And so, yeah, so over time, these like kind of chains of learning and reproduction create lineages that persist over time. So I think that's a very much a cultural attraction AOR idea, but I think this framework in general is consistent with a lot of different views on cultural evolution. And together, kind of the processes of transmission variation create a bunch of associated lineages that make up a cultural form. So in music genres, we can think about all of the associated social and aesthetic and musical ideas that together make up what we call pop music, or in this case, metal music. And this form circulates amongst a group of actors or people, right? And these people are anybody who shares these ideas. They can be arrayed in a social field. They can be arrayed in a very heterogeneous network. But anybody who has an idea is part of the population that supports the cultural form. So this could be, yeah, so this could be someone who is a metal artist or a runs a label, or it could be just someone who's heard metal on the radio twice and says, oh yeah, I know what metal is, it has loud guitars. And so I'm setting all this up so that we can think about how major historical events or macroevolutionary mechanisms can shape this population of ideas over large and long frames of analysis. And I think that's really where the macroevolutionary perspective has real analytic value in complementing some other approaches that are popular in cultural evolution that are more focused on individual people and kind of process level things at the population level or at the micro level. Great, so why look at cultural objects? Well, for one, we can't peer into people's minds and see ideas, so that's a good reason. And second, if we want to do kind of historical empirical analyses, this is what we have information about, right? In general, we have a lot richer information about cultural objects and understanding cultural diversity through objects than we might about what people think or what they have said in the past, or information we have about actors. And I think even today, if you're interested in doing cultural evolution analyses with digital trace data on the internet, it's still true that object level data, stuff about tweets or hashtags or whatever, is a lot more accessible than information about individuals. So we're going to look at diversity of cultural objects over time as a proxy for ideas. For example, you can think about albums as representing diversity of ideas in music genres. And so albums can tell us about cultural lineages represented by bands. So bands have a lot of ideas associated with them. They can be musical ideas, they can be cultural ideas, social ideas, they can be aesthetic ideas. And so at least in this case study that I'm going to show you, we're going to look at birth and death times to reconstruct the birth and death of metal bands over time. So we can look at the first album. The first album of the band is the birth of the band, and either the breakup time or the last album they have as the death of the band. Cool. So what do birth and death rates really mean, right? So the simplest way to think about this is the birth rate is the number of births in a certain time unit, let's say a year, over the population size, and the deaths would be number of deaths in a certain time unit over the population size. And yeah, this kind of model theoretically captures, in an evolutionary framework, the concept of ideas begetting ideas and ideas dying within a population without kind of explicit assumptions made in, say, phylogenies about bifurcation or whatever. So now I just want to give you some intuition for what looking at birth and death rates looks like and how we might interpret these types of things as analysts. So I have no idea how this is going to work, but I'd like to try and play a game with you, the audience. And if they have space in chat, that would be great. If not, I'll just give people a couple seconds to think about it. I don't know, Erik, if that's possible, but we'll give it a shot. So basically, these are the rates over time, some arbitrary amount of time, and these are simulated rates. And the blue line is going to be the birth rate over time, and the red line is the death rate. And so if we have a population of objects that are giving birth and dying, what do you think is going to happen to the population over time if the blue line is greater than the red line consistently? Birth rate is higher than the death rate consistently. Is it going to stay the same, grow, or shrink? Yeah. Right. Yeah. So population increases. Okay. So now the next question is, how do you think it's going to increase? Do you think it's going to increase linearly, super linearly? What do you think? Okay, so I see a couple different things. So that's great. So we can look at that. So in the models, now I'm going to see if I can switch screens. I'm going to show you how we simulate this, and you can see what actually is borne out. So I'm going to share a different screen. Everybody can see me. Are we good? Yeah, so this is actually what Colab looks like. If you have any experience with Jupyter notebooks, it's kind of an interactive notebook with text and code and LaTeX and images. These are a lot of the things that Erik talked about earlier. You can see you can embed R code here. We don't run it because we're in Python, but you can have either R notebooks or Python notebooks. So here I'm going to show you a simulator. And the idea behind this simulator is we're going to simulate population change of objects over time. So let's say we're interested in 50 years here, a population change over 50 years. And what we're going to do is simulate this in continuous time. So we could imagine an individual can give birth or die every day, right? So actually, even though we're talking about 50 years, we're going to multiply it times 100, or yes, the notebooks are all on the website. I see in the chat. So if you go to the website, these are our tutorials. So they are all in these collab notebooks. So you can find them on the website for our module. Anyway, yeah, so you have kind of population change. We're going to look at, let's say, every day in 50 years. So that would be like 400,000 time units or something like that. And we're going to set the starting population size to say 100. And then every day we are going to flip a coin. And we're going to say with a, let's say, 0.2% chance, 20% chance an individual is going to beget another individual. And with a 10% chance an individual is going to die every day. And let's see what happens, if this is going to work. Okay, so I'll look at the birth and death rates first, right? So the solid blue line is the theoretical birth rate. That's what we said was 0.2. And same with the red line, that's the death rate. And you can see when we actually flip the coins, there's a lot of stochasticity in the rates. Yeah, and but eventually as the population size grows, that kind of stochasticity becomes less obvious. And for those of you who said linear or exponential, I think it also depends. You can certainly zoom in and growth might look linear, but over the long term, if growth is, the birth rate is consistently higher than the death rate, it will grow exponentially. Cool. So that's just kind of give you an intuition of what we mean by this. I'm going to go back to the slides. Let's see. Right. So yeah. So within this, we can also see. Let's see. Other evolutionary mechanisms of interest now. So like, for example, this is what a mass extinction or significant extinction might look like, right? It would be a major spike in the death rates, kills off a bunch of individuals, and that creates space and the carrying capacity for new ideas. So the birth rate is going to rise to fill that space. And when I think about the carrying capacity in a cultural form, I'm thinking about the kind of carrying capacity of time, attention, memory, motivation that actors have to think about and reproduce this cultural form. So in this case, music genres over time. So to motivate the kind of statistical model we need here, I'm going back to the simulation I just showed you. And here there's a lot of fluctuation in the rates, right? And so this kind of, it's hard to say that if there was all this kind of stochastic fluctuation in rates that we see in real data, that we could interpret what types of evolutionary mechanisms are actually in process here. So that's the motivation for having a statistical model. And the statistical model that we're going to use is the linear birth-death process. So this was introduced in the 50s. It's very popular for a lot of applications in biology and also in queuing theory and computer science. And basically, it's modeling change in a population over time. So kind of a growth of a population by 1 unit being birth, or death of, or shrinking of a population by 1 unit by something dying. And if you're familiar with Poisson processes, this should look like, this should look like pretty familiar to you of like 2 Poisson processes slammed together, right? So lambda is the birth rate and mu is the death rate. So we have 2 events components, and then we have exponentially weighted waiting times for both birth and death. And again, this is continuous time. So more intuitively, we thought about births over total standing diversity. But here we're going to look at total time lived by the population, because in any moment during an individual's lifespan, they could give birth or die. Okay, and so we're going to infer lambda and mu, the birth and death rates, via Bayesian inference from the times of birth in the population. So in this case, the birth times of bands or the dissolution times of bands. So that's S and D. Okay, so now that we have kind of a formal model for thinking about this, this is what the second module I think is about, is really, first or second module is about giving you an intuition for these birth-death processes. I think the third and the fourth module are built around what Erik featured in his half of the presentation, which is an unsupervised machine learning algorithm called light rate. And this is adapted from work that Daniele had been doing for paleontological models. But the idea here is this is a algorithm that can help you generate hypotheses about what is happening in your population over time and identify major historical events. So the way the algorithm works is it uses a special type of Markov chain Monte Carlo called reversible jump Markov chain Monte Carlo, which allows the number of parameters in the model to vary over the course of the Markov chain. And what's going on here is birth-death processes are kind of what I showed you before. They're always linear. So the birth rate is flat and the death rate is flat. And so what the model does is it proposes to concatenate birth and death, multiple birth-death processes together throughout the course of the model, throughout the course of time. And it will basically fit the model to the data. And so some additional birth rates will be accepted and some will be rejected. So in the top row, you can kind of see how this might happen. You start with a single birth and death rate. The model proposes to add a birth rate, a shift in birth rates. Then it proposes to add a shift in death rates. And ultimately it decides that a better fit would be to remove that first birth rate shift, excuse me. So at the end, you end up with a bunch of birth-death processes concatenating together. And at the joints of these birth-death processes are significant shifts, statistically significant shifts that correspond with either major historical events or evolutionary mechanisms like the mass extinction I showed you before. And the output of light rate also gives you Bayes factors to assess how significant these shifts are. So that's kind of a broad idea of how the model works. Could go into more detail. Daniele, I think, might even be here. I don't know if people have questions about that. Right, so the way I think about this is a way to generate hypotheses. This is a way for you to see the tempo of change, a way for you to see where major events are happening and maybe get an idea of what those rate shifts are suggesting. So the next part is to kind of draw on mechanisms from macroevolution biology for interpreting these types of rates. So we can, so I showed you a mass extinction there. We can also look at competition. So in competition, birth rates and death rates, birth rates might decline to meet carrying capacity, death rates might grow to meet carrying capacity. If birth rates and death rates, once you're at carrying capacity, birth and death rates will converge. So if there is limited resources for ideas, limited time, attention, memory, motivation, etc., birth rates will start out high, but they'll slowly decrease over time. And as resources, niches get filled up, the death rates will increase over time and eventually they'll converge. So in the bottom row, I've shown you what the population size or diversity looks like. And the purple lines are, purple line is carrying capacity. In the third column, we can imagine that carrying capacity, another model would be to make the carrying capacity change in some way. So here we've made the carrying capacity change as a function of a key innovation. So it grows as a logistic curve as new ideas enter the population and create space for more ideas. And lastly, you could say, I don't believe any of this evolutionary mechanism stuff. I just want to see whether birth and death rates follow some exogenous trend. So this might be, if you're interested in climate change, this might be climate temperatures in a biological context, or in the music context, maybe you don't believe in evolution mechanisms and you want to just see, do birth and death rates of metal bands follow popular trends in popular music, so Billboard charts. So I made up some random trend there in orange, and then you can just see how a nonlinear function of that trend might manifest as birth, death rates, and diversity. Okay, so now I'm going to talk a little bit about metal music. So I think this is a fun case study that I've been working on for a couple years now. I'll have the link to the paper at the bottom if you're interested. It's on Social Archive. But it's a cool data set where we have pretty much every band from 1968 to 2000. Metal is an interesting case study because it's like a classic cultural form. Music genres are classic cultural forms where we can think about evolution very clearly in terms of, ideas begetting ideas. It has great qualitative coverage with highs. Metal was one of the top popular music forms at the end of the 80s. Lows, there's a really interesting moral panic in the mid 80s where Tipper Gore and others claimed that metal music and Dungeons and Dragons were ruining Christian values. There's also a saga of church burnings and murder and the origins of the Norwegian black metal scene, which is really interesting. So there's a lot of interesting history and sociology of metal music over time. And the last thing is we have a really unique data set of 30,000 bands that were active over this period and 100,000 albums they've released. So the data set is from this website called the Encyclopedia Metallum. It's really great. So in order to be so you can see that there's both the birth and death times of the bands, there's genre information, there's spatial information, there's the full discography and personnel for each album. The data set is really interesting because it's manually curated. So in order to be in the database, a band has to have a recording submitted with it. And then the moderation team decides whether it is indeed metal or not metal. So music genres are fuzzy concepts, but this is a cool data set because it includes tens of thousands of garage bands and touring bands that are not in a database like Spotify or iTunes and are kind of by their own community identified as belonging to this cultural form. So I'm going to go through, I know I don't have that much time left, but I'm going to go through real quickly some analyses and give you an intuition for what we're doing. So the first is going to be like the light rate exploration and generate hypotheses. And I'm going to show you a competition model and then competition with modifying the carrying capacity due to key innovation. And then I'm going to compare that to an alternative hypothesis. And then the kind of takeaway is that the genre has been fundamentally shaped by competition for the time, attention, memory, motivation that actors have to think about and reproduce metal over time over this period. So the first thing to do is run the light rate analysis. And based on my own reading and what we see in the light rate analysis, I've partitioned this into 5 historically significant phases where the rates change and they're separated by statistically significant rate shifts. So I think the key takeaway from this light rate analysis is you can see the birth rates decline over time over a large period of history, and the death rates rise. And so that looks like it's consistent with some type of competition, even if they don't eventually meet themselves within the period of 1960 to 2000. They look like this is a signature consistent with competition and rates. So in phase 1, which is like 1968 to 1978, that's like the early period of the genre. And there's a few bands, 10 to 50 bands, they're just experimenting and trying out new sounds. And by the late 80s, that kind of coalesces around a core understanding of like, yes, these are going to be the social, aesthetic, and musical ideas that make up metal, this hyper-masculine aesthetic, loud guitars, etc. And that explodes with the new wave of British heavy metal from 1978 to 1981. So we see that. And basically the 1980s correspond with the heyday of metal music, right? So it's interesting that there's kind of a consistent decline with an interruption between 1988 and 1994 of birth rates over that time. What's really interesting is like we might expect to see a mass extinction when metal is effectively supplanted by grunge music in the late 80s and early 90s, like the release of Nirvana's Nevermind is 1991. We don't see that. We do see kind of a interruption in this decline of birth rates, but we don't see a spike in death rates. So that's something already very interesting. So yeah, I think I'm going to go pretty quickly, but here is like in the last tutorial, you can experiment with some of these formalizations of these models. So to model competition, we make birth and death rates a function of the amount of the carrying capacity that's filled over time. And then there's another model which varies that by making the carrying capacity not static over time, but a logistic curve to model key innovation. And when you look at the data here, again, here are the estimated birth rates in blue, empirical birth rates, the just over, birth overstanding diversity in the dashed lines. The competition model fits it okay from 1987 on, let's say, but it's really cool that just by having competition with this logistic curve growing carrying capacity from 1968 to 2000 fits the kind of the whole trajectory of the birth rates pretty well. So yeah, so our interpretation of this is basically the carrying capacity, and here we've shown the carrying capacities for both models. First one is static carrying capacity, purple is logistic. But basically from 1968 to 1978, the carrying capacity is very small. You can only really support a few bands because the space of ideas that are acceptable as metal music is pretty limited. And that changes from 1978 to 1981. So the cool thing about this model, which I think could be relevant in a lot of contexts, is that there are two interesting quantities. The midpoint of the logistic curve is like the peak of key innovation, and you can estimate a maximum carrying capacity, like what is the effective capacity that this population could actually sustain. So the competition hypothesis is not a slam dunk because our models didn't estimate competition and death rates. And moreover, the birth rates and death rates don't converge within our window of analysis. But I did want to look for competition signatures in other contexts within metal music. So these are bands within the 7 biggest subgenres of metal music. And what you can see is particularly in popular music forms like thrash metal and heavy metal, you do see like textbook competition signatures where birth rates and death rates converge. That's the second and third panel and the second and third column, second and third column, first row. And then we also looked at subgenres, which is like, does the birth of new subgenres and new genres in metal change over time? So metal fans love subgenres. So subgenre examples might be within death metal, you might have brutal death metal or blackened death metal. Those are subgenres. And what we see is in all of these major genres, the birth of subgenres slowly declines over time. And in metal overall, which is the bottom row, subgenres decline, the birth rates decline over time. And eventually by 1997, there are no new subgenres being born in metal, no new genres being born in metal music, sorry. So the last thing I want to show you here is to kind of support this idea is an entropy analysis. So Erik mentioned entropy, and the idea here is basically entropy can be kind of a measure of the evenness of distributions of quantities across categories, right? So the Shannon entropy, we can think about, this is looking at the distribution of bands across genres or within genres across subgenres. And then what we do here is we normalize it by the maximum possible entropy. So this is, in ecology, it's called the PLO evenness, but this would be, what does the entropy look like compared to the maximum entropy, where you would allocate a single band or an even number of bands to every single genre possible. And what we see is basically, even though the number of bands are growing over time and the number of genres are growing over time, the proportion of the genre space that gets filled over time is pretty constant, both at the genre level and the subgenre level. You know, some genres become more popular and less popular over time, but bands only effectively explore a fixed proportion of the genre space available to them at any given time. And I think that's consistent with a real kind of cultural carrying capacity idea and reinforces the competition hypothesis. Yeah, and so the last model that you can try in analysis 5, I think, and is a model in the GitHub as well, is you can do an exogenous trend. So here the exogenous trend is metal's popularity on the Billboard charts. From 1988 to 1993, you can see popularity spikes, and that's consistent with metal's golden age, and then replacement by grunge music declines pretty precipitously in the 1990s. But that is actually not a very good model for the rates we see. Maybe it captures the decline at the end of metal, consistent with metal's fall from grace and replacement by grunge or new metal or whatever. But it doesn't seem like a good kind of explanation of how metal changed in the big picture over this time period. So yeah, so I think what I want to go with here is have you take home, like, these are really interesting models. With a little bit of theory from macroevolution, we can generate some really interesting hypotheses, and we can use pretty minimal data to do exploration. We don't need rich data on actors. We don't need network structure between ideas. All we need is birth and death times of objects. And we can look at cultural change using birth-death processes. So for the actual case study, metal's growth is best explained by competition and cultural carrying capacity due to key innovation. And this like top-down macroevolutionary approach is useful for answering kind of long-term historical questions where you're interested in change over larger and longer frames of analysis. Yeah, and diversification rate analysis is natural for thinking about this. I think I'm just going to stop there so that we have time for questions.
Thank you very much, guys. Very interesting. Thank you. And we do have some questions here. The first couple, I think, is more about definition, and it's I guess it's mostly for Erik. It seems to me that your definition of culture is lacking in that it doesn't seem to include overall idea systems that prescribe culturally appropriate behavior. In other words, a similar one, how about the reproduction of ideas?
Yeah, so both good questions. And I mean, I think, of course, the focus of our talk was on sort of making sure that culture had a definition that included sort of the material objects to them and really including that into how we see culture. I mean, in terms of the idea systems, I guess I would sort of more place that in the representations and the mental representations that we're talking about, and sort of the beliefs and skills and practices and ideas that are in the minds of individuals. And those are all present, and not saying that those aren't important factors. We're more interested in how those are represented in a material fashion and sort of in the objects that we see. So I don't think it precludes sort of any sort of ideas. We just have a more specific emphasis on the materials. But I don't know, Bernie, if you have anything to add to that.
Yeah, could you repeat the question or tell me where it is, Sergey, so I can, it's just the first one?
There was the first and the third one, but I think we're gone because I clicked.
Okay. Or Erik, could you just tell me what the question was real quick? Sorry. Yeah, either of you.
Well, somebody questioned the definition that Erik gave at the beginning because it looked like it missed the definition of culture. It looked like it missed ideas.
I see.
I think you, Bernie, you included it in your definition.
Yeah, I think, yeah, for me, I've been thinking a lot about this. I don't know whether this is how anthropologists think about culture, but I do think in sociology, this distinction between personal culture, which is like things in your brain, and kind of public culture is useful. And for me, what's really valuable about cultural evolution is a way of linking those types of change in both of those things, that through learning and reproduction and interaction, people update the schemata of the world. At the same time, the objects they produce, are changing. And so when objects fall into disuse or disappear, that's consistent with changes in ideas in personal culture. Yeah.
Right. And actually, we have a couple of more questions about definitions, I guess. So let's talk about this. Great talk. Wait, where is it? Oh yeah, is there a difference between the way you think about lineages and the way our cultural evolutionary theories, like Morin, think about traditions. How are these concepts similar or different? So lineages versus traditions.
Yeah, I would tend to see, and I don't remember Olivier's exact definition of traditions off the top of my head, but I see them as almost similar, very similar to each other. If you take, at least from an archaeological tradition like mine, the term traditions is, the definition of it is almost exactly like a lineage, something that it has sort of coherency through time and has sort of historical continuity to it. So I would see them as very similar to each other, but there may be smaller technical differences I'm not aware of, but I would put them as pretty similar.
Okay. Another is another one. Do lineages make up a cultural form, or where are the material and social manifestation of the cultural form, and it exists in individual minds?
Yeah, I mean, I think, you know, again, this is my reading on cultural evolution stuff. I have read some of both of the kind of dual inheritance theory and kind of the cultural attraction stuff. And I think really consistent with any type of cultural evolution framework that you want. But for me, yeah, I think that culture, again, exists both in your brains and in public culture, and those things are kind of inextricably tied. And so, again, like material objects are interesting because they're representative of personal culture. Not that they're more important, but it's hard to study personal culture, and particularly in historical analyses. I think a lot of, you know, these methods are complementary to a lot of other cultural evolution frameworks, or rather methodologies, because this is something that we can study historical data without making the assumptions of phylogenies, strict assumptions of phylogenies. And that's not something that complements something like simulations or networks or experiments or ethnographies, which have their own strengths. And yeah, there's something to be said about, you know, minimal data requirements and having the 10,000 foot view for certain types of data. Yeah.
Okay. And then we have two questions about cars. A place where there seems to have been a loss of diversity is a color. Most cars today are black, white, silver, or gray, with occasional blue or red. And the second question is, which models have changed the least or stayed stable, like sharks? And what does it mean for cultural evolution? What are the factors, I guess, that define that?
Yeah, so I'll take the second question first, and because it is sort of an interesting outcome that we found, and the car models that stayed the longest were sports cars. So Ford Mustang, Chevy Corvette, Dodge Viper in some cases. And that's where we see the longest lifespan. So I guess you could argue that they have a very special niche for a special consumer who is looking for that type of car. And therefore maybe that extends their lifespan more. So definitely a sort of an interesting question. In terms of the changes in colors, this is really about how we quantify diversity. You know, does a change in color really change the car model itself, which is our unit of analysis? So we get a lot of change within some of these, within the car models, color, different features, you know, things like anti-lock brakes or changes in sort of how motors run. And often we see those as sort of those minor changes, but they're not actually changing the car model itself. That car model is still, the essence of that car model is still there, despite necessarily changes in color. So we can see those sort of minor changes occur, but I wouldn't actually see those as sort of losses in diversity in car models as a whole across the entire automotive industry. But it's a scalar issue on how you want to define, you know, what you see as traits changing as what would be a loss in loss or gain in diversity.
Mm-hmm. Okay, thanks. And there is also a question, I think, again, more about definitions. So about the differences between micro and macro evolution, because in both cases, you can talk about diversification, origination, and extinction. So can you comment on that? I guess
Sure,
what is micro and what is macro?
Yeah, it's sort of, you can tell I was sort of, danced around sort of trying to define exactly, where micro and macro fits in this. But I think one of this analysis, right, it is very scalar. So if we're dealing with lineages at a macro scale, because our data set's at that scale, our data set is over a long time period, it's over sort of multiple sort of lineages. And so we are examining that at that sort of approach. If you have sort of data that's within a population, or you're talking about sort of how different, in our case, lineages, or if you define lineages some way else within a population, then yes, you could probably talk about things like origination and extinction within a population. So if we want to call that microevolution, then I think you can certainly define it that way as well. So
yeah,
Bernie, you want to comment?
Yeah, I guess I would say that's, the distinction between macroevolution and microevolution biology is something that's also, I don't know about tenuous, but what do we mean when we're looking at a macroevolutionary lineage of interest? It could be a species, it could be a clade, and the distinction between micro and macroevolution of biology, I guess, happens at the order of a species. But I do think these ideas, I think more than this is the right way of thinking about this for a culture, or this is the wrong way, I do think it's up to the analyst to kind of pick cultural lineages that make sense for their theory and their data and their questions. So there's that. I will say that something I'm interested in expanding these models, which is kind of like a catch-22, which would make it more clearly a macroevolutionary thing, is with biological data in paleontology, we don't know a lot about the abundance of species tens or hundreds of millions of years ago. For something like metal bands, we might be interested in some measures of abundance or saliency in terms of album sales or car sales or whatever. So I think, yeah, I guess this is somewhat of a ramble where I'm going with this, but I do think, if we had included that, it would have been oh, obviously those would be population level characteristics, like the abundance of individuals. And clearly we're thinking about categories, right? We're thinking about car categories or band categories. So I think that distinction is not super clear. And to me, I think that's more of a context specific question and answer. Yeah.
Okay, thanks. And then there is a question more of a technical nature, I think. It concerns the way you estimate the rates. So in your talk, you were basically applying methods that evolutionary biologists developed. So the first part of this question is, how do you ensure that the material cultural traits are mainly transmitted vertically? That would make evolutionary biology framework applicable. And then the second part mentions a recent paper by Luca and Panel that showed that we cannot estimate extinction and diversification rates in phylogeny. So that there is an infinite number of different sets of these two parameters that are equally good.
Yeah, so two excellent questions. I mean, in terms of how do you assume a lineage is vertically transmitted? I mean, it sort of depends. I mean, you can make it a conceptual assumption that it's there. In archaeology, typically this has been to look at lineages and sort of do a seriation technique where we look for the sort of classic battleship curve or some sort of cycle of waxing and waning, which would then give some sort of suggestion that this is a sort of vertically transmitted sort of characteristic. Whether that's the appropriate way to do it, I think is an open question and a very valid question we have in cultural evolution. I mean, in this particular case, we're often assuming that there is that sort of vertical transmission within these lineages. As for the second part about estimating extinction and diversification rates from analyses, that's a really open question. I mean, I'm not familiar with the Luca and Penno paper, but it looks very interesting. I mean, there's been a lot of debate, certainly around things like BAM and whether or not how well it estimates diversification rates from phylogeny, how well extinction rates can be estimated. That's a really interesting area that I don't know if there's a specific answer to that question right now. I think hopefully what we can show is that by knowing the extinction rate, or at least estimating the extinction rate, you do see interesting dynamics that occur by knowing that, and that it's a very valuable part of the equation in terms of knowing how origination and extinction play off of each other. That's really important for understanding processes of diversification.
I guess I would follow up with that and say that maybe this follows up on the last question about the scale of analysis that you're looking at. But I don't think that these models make as strict assumptions about vertical transmission in the same way that phylogenies do. These birth-death processes are just capturing ideas begetting ideas. So whether that's happening in a vertical way or a horizontal way, I think it's definitely a weaker assumption, I guess, than what's made in phylogenies for sure. And in the same way, I'm not sure that the issues that the Luca and Penno paper, I have to read it, but I'm not sure they would apply to this application of birth-death processes, that the same issues manifest because of the assumptions in phylogenies. But I think those are good questions. I'd have to think more and read more about it, yeah.
Thank you. The next two, would this analysis generalize to other fads and fashion trends? And would this provide a predictive model?
So I hope so. I mean, I think we showed two examples here. There's a paper, I mean, this stuff is less popular now. I think we're trying to revitalize interest in it, but there's a paper maybe 15 years ago in a book by a sociologist called Stanley Lieberson about how the popularity of baby names changes over time, over 60, 70 years. It's a really fun book, and it's a really fun kind of cultural macroevolution question about why certain types of baby names become popular, why they cycle in and out of fashions and trends. And yeah, I think so I think there are a lot of contexts where these types of questions are applicable. And again, I think it's thinking about whether the theoretical assumptions of birth-death processes are reasonable in your context and whether you have a theoretical question that fits. And then the second question is like, are these things predictive? I think that's really hard. I had originally, in an older version of the Meadow paper, there was a question of whether we could do some predicting of the carrying capacity into the future. And I think at the scale that we're talking about, there's just a lot of underlying factors that are happening, a lot of things that are happening. And so it's very hard to make predictions days into the future or months into the future. And at the scales of analysis that we're doing things, yeah, I think those would be I think they're stronger claims than I had initially, given credit to. So maybe something like the maximum carrying capacity could be used as predictive, but I would definitely take it with a grain of salt. Sorry, go ahead, Erik.
Yeah, no, we try a predictive model with cars in a 2016 paper, and where we take the rates at the sort of last point in time, in that case 2016, and we then try to see what the richness or diversity would be for different car models, specifically for electric cars versus gasoline-powered cars, and at least try to give ourselves a sense of what the prediction would be for the number of car models and sort of when they would reach sort of equal numbers of car models available between electric and gas-powered cars, given the current rates that we saw and the trajectory we saw. And then we sort of estimated that by 2040, we should have roughly similar numbers of electric and gasoline-powered cars on the market. But it's a pretty tenuous predictive model, but we do attempt something like that.
Well, you guys probably should think more about that because there is big money involved When people invent something new, different models emerge, like different operational systems or different computers, and there is diversification, and when there is kind of a decline. So decline happens when a dominant design appears. So this is the time when you have to sell your stocks and things like that. So I've seen books on that, so you might want to check
that's what we argue for with the cars in our 2016 paper, is a dominant designs process or a path dependence process that locks in the technology into a certain type or model style, which is why we see the decline really from the early 1980s. And it's a well-known phenomenon, dominant designs in economics and really in the car industry in general. And so we have sort of applied this to a number of other systems as well. We've looked at pharmaceutical drugs and the diversification rates of pharmaceutical drugs. We looked at apps from the App Store and the pace of diversification with App Store apps, and also Linux operating systems and sort of the pace or tempo of diversification in those systems as well. So those are all sort of various conference papers that we haven't published, but it is one of the advantages. It's easily flexible to different systems as long as you have a strong sense of what that lineage is and the sort of temporal dimensions of that. If you have a good sense of that, then you can really use it on ideas or whatever you might be looking for.
Okay. And then there is a question about how you apply these ideas to studies of the growth and depth of ideas. Must the study of ideas always be proxied through concrete material culture? How you operationalize your approach,
So I think
application to ideas?
I think my response to that is probably pragmatic and annoying, which is, of course, you can study ideas, but on some level, you have to be looking at something, which is archival materials or survey responses. And to me, those also constitute as like material objects. Even if you want to be really annoying, I even think speech is a material. Speech is something that's very ephemeral. But it does exist in the material world. It's not purely something that's cognitive. So that would be my response to that. But obviously, if you have some way of measuring ideas, then there's no reason you can't apply these methods. I think it's just, like any type of modeling framework, it's about having something that fits the assumptions and is appropriate for the questions that you're asking. Yeah. You want to add anything, Erik? Or?
Nope, I think that's a great answer.
Yeah. Thanks. And then there is the last one, and it's an interesting question because biologists also encounter it. So how you distinguish the properties of the lineage or some changes in a lineage specific for the lineage from a general trend? And that's an application to the color, to the car color.
Yeah, good question. I think it depends on how you see the color. I think Bernie did a nice job sort of presenting. If you have sort of some exogenous thing, you think, whether that be popularity and billboard charts or whatever, you can sort of correlate that with the diversification rates we see. So if you view that as a sort of an exogenous trend outside of what makes the car model, what we define each car model, then I think you can use in that scope. If you think of it's something within each lineage, then you're going to have to sort of adjust what you think that car model is and whether or not you incorporate that in how you define these different lineages. And I think ultimately what you can really do is have a number of different ways in which you can define the lineages. There's no reason to suggest there's one specific classification scheme that has to work. You can adjust it. So if you can have a more detailed classification scheme and look at, say, car model trim rather than just the model, you can even upscale it and just look at manufacturers as we've done before. So I think it's that sort of scalability and sort of deciding where you think that particular trait falls in and how to best incorporate that trait into your classification scheme. So classification is a difficult problem in every discipline. And I think it's something hopefully that our framework here sort of really brings to the forefront on how important it is and how important those decisions you make in classification can be when you're talking about patterns of diversity.
Okay, well, that's all. Thank you very much for great talks, and thanks to everybody for your questions. So yeah, hope to see you next week. And next week we have Peter Torshin, who will be talking about the evolution of social complexity. Thank you, everybody. Have a
Thank
good
you,
day.
Sergey and
Thank
Erik,
you. Cheers.
for
Okay.
putting this on. Yeah, this is
Great.
really fun.
Thank you.
Thank you, guys.
Thanks everybody for
Bye.
attending. Oh, there's a GitHub also. If anybody has issues, they can put issues there and I'll try and respond to them. And yeah, you can email me or Erik if you have questions.
Absolutely.
Mhm.